Day 34, solid, liquid, gas. Okay, when we think about the solid, liquid, and gas state, we're thinking about mainly the three states of matter. There are other states of matter, but we're going to associate right now just with these three, solid, liquid, and gas. The best way to do this is to draw a picture, and we'll put solid, liquid, and gas. Now, if I go from the solid state to the liquid state, solid to liquid, that's called melting. Melting, solid to the liquid state. And if I go from the liquid state to the solid state, then that would be freezing. Okay, so I'm going to put a little 1 here for the melting, and then 2 for the freezing. All right, so 2 goes right there for the freezing. Now we're going to do condensation. If you're going to condense something, you're going to go from the gas state to the liquid state. That's called condensation. And then if we go from the liquid state to the gas state, that is called evaporation. All right, so that's evaporation. Now most students know the answer to those first 4, but it's these next 2 that sometimes get overlooked. And so what we want to do is we want to make sure that we get from the gas to the solid and the solid to the gas state. Number 5, sublimation. Sublimation is going from the solid state to the gas state. So we go directly from the solid state to the gas, that's sublimation. And when we go from the gas state to the solid state, that would be deposition. Gas to the solid, deposition. So the best way to do this is to draw your little triangle, put your solid, liquid, and gas in there, and just draw the arrows and fill it in. So just make sure you know the transitions from each state. All right, now let's draw another picture. What we want to do is we want to look at a picture that has to deal with pressure and temperature. Now the pressure and temperature picture is going to look something like this and this. And we are going to have the solid state, the liquid state, and this is going to be the gas state. Now for a certain pressure and a certain temperature, we can be in the solid state. By keeping the pressure constant and just increasing the temperature, we go from the solid state into the liquid state. Then, of course, we call that melting again. And then we could also increase the temperature from the liquid state and go directly into the gas state. And from the liquid state to the gas state, we would call that evaporation. Now, what we could also do is we could be in the solid state. We could increase the temperature a little bit at a specific pressure and go directly into the gas state. Or we could be in the solid state and we could keep the temperature constant, just lower the pressure. And when we lower the pressure, we can go into the gas state. And we can always do the reverse of these as well. We can go from the liquid to the solid, from the gas to the liquid, liquid to solid, freezing, gas to liquid. We call that condensation. And from the gas state directly into the solid state, there is our deposition. Remember, our solid state to the gas state is sublimation. All right, now if we're in the gas state, we can also go directly into the liquid state. Go from the gas state directly to the liquid state by keeping the temperature constant and just increasing the pressure. You may have a gas grill that you have to barbecue out on, and so that gas grill has a propane tank. And so that propane tank, when you go to fill it up and you try to shake it, you can feel that there is a liquid inside that tank. That gas is under such intense pressure that it is now in a liquid state. And when you go to turn your gas grill on, what you're doing is you're lowering the pressure so that LP gas, that liquid propane gas, can go directly into the vapor state, into that gas state. so that you can use that gas to grill out and barbecue and have all kinds of fun. Now there's a really interesting feature here where they all manage to come along together at a specific temperature and a specific pressure. All three states of matter coexist. You can have the solid, liquid, and gas state all occurring at the same time. Now that is really crazy, but it's true. You can have it at a certain pressure and a certain temperature. You can have solid ice, liquid water, and water vapor. This is called the triple point. So right there is called the triple point. Now there's one other piece of information here, and that's this point right there. At a specific temperature called the critical temperature, and a specific pressure called the critical pressure. Once you go beyond them, once you go higher than the critical pressure and the critical temperature, what happens is that the liquid and gas phases are no longer distinguishable. This substance has a special name. It's called a supercritical fluid. So just to clarify, once our temperature is beyond the critical temperature and our pressure is above the critical pressure, you cannot tell the difference between the gas state and the liquid state. This is called a supercritical fluid. So this is the critical point, and this is the triple point. Now we have one more picture to make, and that's a picture that looks like this. And what we have here is energy on this scale. Sometimes I label energy as delta Q. And on this scale, we are going to put temperature. Okay. What we have is a picture that looks like this. And then we have a part of this, and then this, followed by another stair step, and here we go. Now, at this temperature, this is called the melting point. The melting point is that specific temperature, and this specific temperature would be that of the boiling point. So we have the boiling point and the melting point. You might think, what temperature does ice melt? Or what temperature does water freeze? Now, most people in America will say 32 degrees Fahrenheit. And then I'll question, well, is it really 32 or is it a little bit above 32, like 32.1? You know, what temperature does ice melt and what temperature does water freeze? And it turns out it is the exact temperature called the melting point. And for water, that's 0 degrees Celsius or 32 degrees Fahrenheit. So what we want to do is use this picture to study what really happens at the melting point or the boiling point. So let's get started. In this first region, the temperature is below the melting point. So we are in the solid state of matter. So we are in the solid state of matter along here. So imagine if you took a piece of ice and you took it out of your fridge and you put it in a pan, and now we heat it up. And as you heat up that ice, what happens is the temperature is increasing, and it gets to this point right here, the melting point. At that instant, it is 0 degrees Celsius ice, solid water. Then I add more energy. But notice as I add more energy, the temperature does not change. It changes the state of matter from the solid state to the liquid state. So at this point, I have 100% liquid water. We have solid ice over here and liquid water over here, all at the same temperature as I change the state of matter. But there is an energy change for that. And so we call that energy change is calculated by the latent heat of fusion. L sub F, that latent heat of fusion. So that's what I'm going to use for that. Now we have liquid water at 0 degrees Celsius, and we're going to add energy, keep adding energy until we get to the boiling point. We are in the liquid state, remind you. So from 0 degrees Celsius all the way up to the boiling point, we are now in the liquid state. But now that we're at the boiling point, remember it's 100 degrees Celsius, but it's all liquid water. And if I keep adding energy to this, I will get all 100% water vapor. So we go from 100% liquid water over here to 100% water vapor over here. And then as we increase that temperature, we give it more energy. Now we're in the gas state, and we're taking that water vapor, that steam, and what we're doing is we just keep adding energy to that steam. Okay? So we start off with the ice in the solid state, and we add energy. We get up to the melting point. It's still solid ice. We keep adding energy. We go through the transition from the solid state to the liquid state through this latent heat of fusion. Now we add more energy and our temperature increases more, and we go up to the liquid state all the way up to the boiling point. And then when we get to the boiling point, we keep adding more and more energy, and then we get all the way up to where the water will turn into vapor, 100% vapor. Now this energy transfer is calculated through something called the latent heat of vaporization. So that's what we're going to use there, the latent heat of vaporization. Now that might be a lot to take in, but go back and look at the pictures. If you have questions about them, let me know. So now it's time to get started with the homework and answer those few questions and then take your quiz. And like I said, if you have any questions, you be sure to let me know. Enjoy your day.